very famous. Because I'm projecting to there, it's cutting off my screen, so I have to look here. But Babbage was credited with basically designing the first sort of computer system that could be programmed. So people have always wanted to do calculations, arithmetic, as fast as we can, and there's always been, well, not always, but sometime in the Middle Ages, people started building calculating machines that would do arithmetic. But they still had to be operated by humans, and they were very crude and primitive and not very fast at all. So Babbage decided to build a computer. And his idea was that this was pre-electronics era. I think they had discovered electricity by then, but it wasn't, something that was really widespread. And his computer was designed to be a mechanical computer. And somewhere, there's probably a picture here. So the first machine that he constructed was called the difference engine. And it's all mechanical. And I have no clue how this thing works, but it's got these gears that can turn, and I believe it was based on decimal. So it was a base 10 computer system, a decimal computer system rather than binary. And I think he constructed part of the difference engine and got it to work. But the difference engine had some limitations, and so he decided to design a follow-up machine. And the follow-up machine was called the analytical engine. And he designed this machine. Again, it was mechanical, and it was based on base 10 again, I think. And I was trying to see if there's a picture here. Well, he was trying to design this mechanical programmable computer in 1840 or whenever. And then he worked with a woman, or a woman worked with him, and her name was Ada Lovelace. And she was sort of a privileged, sort of person. And so she grew up studying math, and her health wasn't very good. And somehow she got introduced to Babbage and got to talking to him about this machine he was trying to build. And she designed a program, or some programs, that in theory, if he had built the machine, she had these programs that would do calculations. And she gets credit as being the world's first computer programmer. And there's a language named Ada in her honor. And Ada's actually, I think it's a pretty cool language if you've never looked at it. It's not widely used. When I grew up and was in college in the 80s, Ada was the next great language. So there's always, every 10 years, every generation, there's a new language that's the next, great language. And Java's days hopefully are over. But we had to do our software engineering project in Ada. And it's actually a pretty cool language, but it's not widely used outside of the aerospace industry. So anyway, that's that. That's who Babbage is. And I named my machine Babbage in his honor. I have another computer which is named Turing, after Alan Turing. Well, the plan that I had, first of all, if you're not aware of it, I wanted to make you aware of this, is that ASU has some Linux clusters, machines that you can get an account on if you don't have one. If you go to asu.edu/SelfSub, can I zoom this anyway to make that text larger? Can you see that text okay? I wonder.
You can set your resolution to like 720p or something.
Yeah, I was wondering. I was curious if I could make the resolution different. Let's see. Because all of my windows are being cut off. I can't minimize. Is that it? You know more about this than I do here.
You have a 1366 by
This is an old
768
computer.
display.
It's an ancient computer.
Yeah. Okay. Oh, okay. How do I scroll on this? There we go.
Yeah, 2 fingers. Okay, are we on? So the thing I wanted to point out is if you go to that website, it's actually selfsub.asu.edu. But if you go to that website, now you can subscribe to different things. I'm subscribed to everything because I'm a faculty member, and I guess they just set up our account that way. But if you go to that website, there's the way it worked when I signed up for this was there were radio buttons and you could, or check boxes, and you could click these check boxes to sign up for these various services. And so there's a Unix cluster, a Linux cluster actually, which is this one. So it's the general statistics Unix clusters. And you can get an account on this machine or cluster that they call general. You just subscribe, and then sometime later you'll get an email or something, and then you can log into general using your ASU ID. So I'm going to log into general right now. When I teach the 220 course and we go through the Linux stuff, I just tell the students, if you don't want to mess with installing Linux on your own computer, just use general. So we can do a lot of stuff doing it that way. Oh, one of the nice things about the terminal is you can create commands that you can type to do things, and you can create what are called aliases. So when you fire up your terminal, you're probably going to be running the bash shell. And bash, well, let's talk about shells. I have a URL for my website, which is devlang.com. And if you go to devlang.com, I'm looking for a new hosting site. So this site right now is hosted on the ASU servers. But if you go to devlang.com, it's going to redirect you to my web page that's hosted on the ASU server. And I have a document that I wrote for when I taught 220, because I didn't want to require the students to purchase a new textbook just for Linux, because there's so much information that's available online. So I have what I call the GNU Linux Lab Manual for CSE 220. So I've made that available on my website if you want to look at it. So the first chapter I have just a short history of Unix and GNU and Linux. We'll skip over that. And then the second section, this manual was last updated in 2013, so that was 6 years ago. So this section 2, some of this is a little out of date, but I suggested here different ways for students to get connected to a Linux system if they don't have Linux installed. And so that's that section. Section 3 talks about transferring files, and at the time I wrote this manual, I figured most students were using Windows, and so there's a nice program called WinSCP that you can use to do file uploads to the server and also downloads. Another one that's nice that I use now is FileZilla. Is that what it's called? FileZilla. Yeah. I think I have it installed here, but I'm not sure where. Yeah, FileZilla. So if you have an account on a Linux machine somewhere, you need to be able to transfer files from your PC to that Linux machine or download files. And FileZilla can do that. It's made by the organization that creates Mozilla. And when you fire it up, you'll get two panes. And this pane shows you the files on your own disk. So I'm looking at the files that are in my folder, my home folder /ASU/www. And then I can connect to a server. I have a connection to general setup, I think. This isn't going to work, I suspect. What's going on? Well, I'm not sure. Anyway, the point is that you can transfer files back and forth. So that's convenient if you're doing work on a different Linux machine. Section 4 in my manual starts talking about shells. And then section 5 talks about various commands for doing things like moving files around, copying files, creating directories and stuff. So I thought I would start with 4 and go through 5. Section 6 just talks about the man pages. And section 7 talks about these things called environment variables. And then I've got a section on searching for files, I/O redirection. So I thought I would go through these various sections of the manual and just explain things. And if you have questions about things that I'm not going over but you want to ask, that's perfectly fine. And if everybody understands some topic, there's no point in me going over it. So I want this to be sort of a dynamic, interactive workshop. So let's go to chapter 4. There we go. Okay. So in Unix, traditionally, the way users would interact with the system was through a program called the shell. If you go back to the time when Unix was developed, it was but that was before the microcomputer era. So this Unix was developed right around 1970-71. That time frame, and that was before the computer era. And at that time, a lot of programmers didn't directly interact with the computer systems. They would write their code essentially on by creating what are called punch cards, little cardboard cards that punch holes in them. And then when the programmer wanted to build or compile his or her program, he would take the punch cards to the computing center and give them to the operator. And then the operator would put them in a stack of all of the other jobs to be run. So you go on the bottom, and then eventually your job works its way up to the top, and they would load your punch cards into the machine, and it would read the punch cards and compile your program. If you had a syntax error, you would go back 3 days later and find out that your program didn't compile because you had a syntax error. You left out a semicolon. So you'd go home, fix your punch cards, bring it back, wait 3 days. It was very tedious programming. So a lot of programmers didn't have direct access to the machine. If they had direct access, it was oftentimes through a teletype or a teleprinter, which is essentially a typewriter connected to the computer system. If you just Google search teleprinter, you'll find pictures, whole bunches of them. So there's an example of one. Hello? Well, that's not what I wanted. I was trying to load this image. I don't know. Anyway, they're like typewriters with paper and a keyboard. Then eventually, technology advanced enough to the point where a programmer had an actual monitor sitting on his or her desk and a keyboard, and then he or she could connect to the system that way. Now, this was all basically prior to the graphics era. So computers in those days were just simply text-based. And it wasn't really until the Apple came along that they started building computers with graphical user interfaces. The technology for that was actually developed elsewhere at a company called PARC, which was part of Xerox. And then Steve Jobs went to PARC and was looking around and talking to people, and he saw that they had developed this computer system with a graphical user interface. And Jobs realized that this is the future. This is the direction we should be moving in. And so when the Apple Macintosh, the original one, came out, it was the first microcomputer that I'm aware of that had a graphical user interface. But even nowadays that we have graphical user interfaces, we can still interact with the computer system through a program that acts. The old teleprinters were called terminals. So we have a terminal program that we can run that allows us to interact with the computer system just typing text and just displaying text. And in the Unix world, you can run a program which is called, which these programs are generically called shells. Where'd my document go? I must have closed it. Oh, there it is. So the shell is a program that simulates a terminal, and all it is basically it just allows you to type text, commands, things like that. It sends the commands off to the rest of the operating system to be executed, and it just displays stuff. And there's a lot of things that you can do at the terminal that you can do oftentimes a lot faster than you can if you're going through clicking buttons through a graphical user interface. And so it's pretty handy. If you're going to use Linux a fair amount, it's good to learn some of the basic shell stuff. And I don't know everything. I just know enough to get around. But I'll show you what I do know. Yeah?
Is there so the shell is the terminal that we're using?
Yeah.
Okay, and then...
Well, the terminal is a program which runs a shell.
Okay, so the shell is what's actually...
Yeah.
What we're actually working in?
Yeah. I'm actually running, I'm running X Ubuntu. So Ubuntu is a very popular distro if you're not aware of that. And with Linux, one of the nice things about it is you can select your desktop interface or your environment. So with Windows, you're stuck with what Microsoft gives you. And with Mac, I don't know because I don't know anything about Macs. But in Linux, you can choose your desktop environment from among those that are available. And one of the desktop environments that you can select is called XFCE, if you're interested in that. And XFCE, from what I understand, XFCE doesn't stand for anything, but it's considered to be a lightweight desktop. So some desktops are pretty graphics intensive because they do all kinds of animation and stuff, and when you click Windows, they'll, do little animations, and you can decorate your windows with all kinds of stuff. That would be more of what we would call a heavy desktop environment. And I use XFCE running on Ubuntu because it's a lightweight desktop environment, and I'm using a 7-year-old computer, and so it doesn't have as much power. So that's when you install the distro that you end up installing. if you go with Ubuntu or an Ubuntu-based distro, then you can choose your desktop environment when you install it. And I suppose that's true of Arch and Manjaro and all the other ones. But I'm not going to go over installing Linux. I'm going to assume you have it installed. The shell is called the shell. In operating systems terminology, you've got part of the operating system which interacts directly with the hardware. And this part of the operating system is responsible for doing things like scheduling jobs. So at any one time, you may have 100 different processes running on your system. In Unix terminology, a program that's running is called a process. And you may have 100 processes running at any one time, because you've got all the programs you're running. Each of those is a process, and then you've got all the processes that the operating system is running in the background. There's a command, if you're in your Linux environment, you want to try this, there's a command called top. If you just type top, it will display a list of all the processes that are running, and this column displays the amount of time that that process has consumed since, I guess, the last time you rebooted. I'm not sure what all of these do. This is percentage of CPU. So Firefox is using 6.6% of my CPU right now, and 8% of my memory. And if sometimes I find top to be convenient, because if your system's running really slow, it may be that a process is consuming a huge amount of time. And so if you run top, you can figure out what that process is. Each process in Linux has an ID associated with it. It's called the process identifier. And the PID column gives you the process identifier. Every process has a unique identifier. And they start with 1, and I'm running Ubuntu, which uses systemd. And so that basically comes, when I boot up the system, systemd starts running, and that's process number 1. And then all of these other processes get started, and these are all operating system processes that are running in the background. The ones that are in the user column, the ones that have Kevin beside it, those are the programs I'm running. The programs that are running in the background, those are being run by root. In Linux, you have to have an account to log in, generally. And there's always one account that has sort of like complete control or complete privileges over the operating system. And that account is known as root. So if you're setting up your own Linux system, you can configure root so that when you log in, you'll have access to files and be able to do things that you can't do when you're logged in as Kevin. And normally you should not use the root account. You should only use root when you're making modifications and doing stuff that root needs access to. The reason is if you work in root mode all the time, then you're very likely to screw up something. And when you're logged in as yourself, I don't have the same privileges that root has. So there's folders and directories out here. For example, in user, I'll talk about the directory structure here in a bit, but there's a directory on your system called /usr, which is user /bin. And that's where a lot of the programs that you run, that's where the binaries are. In Linux terminology and Unix terminology, when you create a program and you compile it and generate the program so that you can run it, the program that gets generated is called a binary. In Windows, they call them executables. So in Windows, you'll see a .exe extension if you start digging around in certain folders. That's an executable program that you can run. In Linux and Mac and Unix, they call those binaries. And so user bin stores binaries for a lot of things. And as Kevin, I can't write to user bin. If I try to delete one of these files, or I'm not going to try it because just in case I don't want to delete something, but I should not be able to delete these files. Okay. Unix was designed from the beginning to be a multi-user system, unlike Windows, which was designed to be used by one person, and Mac. Well, Macs basically run Unix, so Macs and Linux are kind of the same in a way. But Windows was designed to be a one-person operating system. Unix was designed from the beginning to be a multi-user operating system. So on a Linux system, there could be 300 different users, with each of those has their own account. Create a new user? I'm running XFCE on Ubuntu, and I think if I go to Settings Manager, now this is XFCE stuff, so if you're running a different system, it may be different. But I was thinking there might be a program on your system that allows you to manipulate users. Oh, here it is. It's users and groups. And I can add a user here. Now, depending on what operating system, oh, by the way, when I click Add User, I'm Kevin. And you need root privileges to add a user. So it's asking me to log in basically as root. So I would have to, if I wanted to proceed here, I would have to type in the root password. Now, I'm not going to do that. So how you do it on your own system through the graphical user interface is going to vary, but there should be some settings or something like that, and within settings there should be a program that you can run that adds a user. There's a way to add users at the command line, but I've forgotten now how to do it. You can always, the great thing about today is you can always Google search everything. So there's one, you've got to create the user with add user. So I guess I would type add user here. And it says only root can do that. But let me log in as root. In Linux, when you're in your terminal, if you want to become, root's called the super user. So if you want to become the super user, you can type, when you run a program, I want to run this program not as Kevin, but I want to run this program as root. Then in Ubuntu and Debian-based distros, you can do sudo, S-U-D-O. And does that just stand for super user do? Yeah. What that does is when I run this command, now I'm not running the command as Kevin, I'm running it as root. And so I have special privileges now. And it's going to ask me for my root password. Okay. And then I didn't give add user the appropriate arguments. In Linux, traditionally, the way these various commands were documented was in a manual that was online on the system. And that manual, in order to read the commands or the pages about the various commands, you type man. Man is short for manual. So if you type man, it'll display a page which explains what the man command does. Man. So if I want to know how the add user command works, I can do man add user. And that'll bring up the documentation. You may find that this is pretty primitive in a way because it's not HTML and it's not all fancy and everything, but it gives you the information you need. Reading a man page is a skill unto itself, but it basically, there will be a name section which is the name of the command. There will be a synopsis section which explains what the arguments are to the command. So when you type a command, you can specify arguments to it. And so the synopsis section will tell you what arguments you can pass. Then there will be a description, and in the description section it'll talk about what the various arguments are and what those do. And you can see with add user that there's quite a few options or arguments that I can pass. Then there will be a section that talks about the return value or exit value. That's useful when you're writing bash scripts. You can write shell scripts that execute commands, and whenever a process ends, it always generates an exit code or a return code. And in bash, if you're writing a shell script and you want to run a process, you can check to see if that process finished normally or not, because most of the time it'll return 0. And if it returns a number other than 0, then that oftentimes means that something went wrong. Okay. We'll talk about scripting later. So how do we do this? It would be add user Does it? Yeah. Most of the time you can do this through the graphical user interface. That's one of those things that it's almost easier to do it through the GUI. Yeah. That's a good question though. Yeah. But now you know how to get the man page up, and you can try to figure it out if you want to. Yeah. It's not tough. I've done it before. I just don't remember right now how to do it. But it's not tough. You have to create the user by doing add user, and then you add them to a group. So users can be added to groups, and you can have various groups for things. So then after you add the user and create the user account, then you can add the user to specific groups. Did you have a question?
Yeah, so
Yes, sir.
So what's the difference between root and bash?
Root has special privileges that normal users don't have. So for example, root has the ability to install programs. And oftentimes, you don't want to give users that ability. And there's certain directories where root needs to go sometimes and modify configuration files that are stored in certain system directories. And again, you don't really want users modifying those configuration files.
So does the user have access to go to the root?
If the user has the root password, the user can become root. But the way you keep users out of that is by not giving away the root password. That's what you keep secret. Yeah. And usually, you know, if you're the system administrator, you might give the root password to somebody else. You know, maybe 3 or 4 or 5 people know it in case you die. But say that. The system administrator is just sort of a generic term for whoever's in charge of maintaining the system. Yeah, right. It's just, I suppose they call them different things in different environments, but traditionally, I learned the term system administrator years ago, and that's just a sort of a generic term for the people who are in charge of maintaining the system and installing programs and stuff like that. Yeah. Yeah, that's right. In Windows, you have the administrator account, which is basically the same as root. Yeah. And Linux is not Unix. So Unix is an operating system that was developed at AT&T Bell Labs starting around 1970, and it was originally written in assembly language, the whole operating system. And writing code, if you've not done assembly language, writing code in assembly language is a little bit tedious and time consuming. If you take CSE 230 at some point, or you'll take EEE 230, you'll learn about assembly language there. So they decided, this is a research environment, so they decided to create a language so that they could write the Unix operating system code in a high-level language instead of doing it in assembly language. And so Dennis Ritchie created the C language. and then they rewrote Unix using the C language. And so Linux is heavily C-based because most of the processes, the programs and things like that, the code is written in either C or C++. And a lot of it's in C. I believe the entire Linux kernel is in C. C++ has some overhead issues that makes it run sometimes a little bit slower than corresponding C code. So finishing what I was saying, so the lowest level of the operating system that's responsible for running these processes, and because you can't run every process at the same time, you've only got, you know, maybe a 4-core CPU. So with 4 cores, in theory, you can only be running 4 programs or processes at any one time. So the operating system, one of its job is to run a process for a little while, then put it to sleep, then run the next one, put it to sleep, run the next one, put it to sleep. And if you do that quickly enough, it appears to the user that these programs are all running simultaneously. But they're not. Each one is just running one at a time, but you just do it real fast. And that's called multitasking in operating system terminology. And all computers today do multitasking, but that was something back in the 60s and 70s that was, you know, sort of novel at that time. The lowest part of the operating system is called the kernel in Unix terminology, the kernel, K-E-R-N-E-L. And so the shell is called the shell because it's a program that sort of surrounds the kernel. Let's see if I can draw a picture where you can see it. They always put the screens right in front of the whiteboards. The people who design these classrooms are idiots. I always get annoyed about that. So if we picture our operating system, we've got the kernel. And the kernel, one of its things is it interacts with the hardware. It schedules processes to run. It manages memory. It does a whole bunch of things that are really important. And then we picture the shell as being this program that surrounds the kernel. And this is what the user interacts with. So the user interacts with the shell by typing commands, and some of those commands work their way down to the kernel, and then something happens. So it's called the shell because it surrounds the kernel. There are different shells you can run. So by default, if you're installing a Debian-based distro, Arch I'm not sure about. I started with Red Hat Linux back in the 90s, and then I switched to Debian, and I used Debian for a while, and then I switched to Ubuntu because it was easier to maintain than Debian. And now I'm using Xubuntu, which is just Ubuntu with the XFCE desktop interface. So depending on what distro you're running, it's going to install at least one shell program. And in general, most of the Debian distros that I'm aware of run a shell called Bash, B-A-S-H. Is that true of Arch?
I think Bash default, you can change it. There's popular shells now like Fish and...
I need to look into some of those. Yeah, because those I've not heard of. Yeah. The original shell program that was created back in the 70s for the Unix system was called SH, and it's just short for shell. Sometime later, Unix was developed in a research environment, and in the beginning they just gave it away freely to academic institutions. It was primarily used in academia. And so they just gave it away. You could even get the source code for it. After a while, it got to be so widely used that AT&T, who owned Unix because it was developed at their research facility, they realized they had something that they could make money on. And so they closed it. It was no longer open source. You couldn't get the source code. And they started selling it and trying to give it away, which was sort of a disaster. But that's what happened. When AT&T decided to start selling it, at the same time, there was a version of Unix that was being developed at Berkeley, University of California, Berkeley. And it was based on Unix, and it was similar, but it was a completely separate rewrite of the operating system. I don't know if they used anything from AT&T Unix. Berkeley, that Berkeley version of Unix is what I learned to use when I was in grad school. Eventually, Berkeley released that, and it became open source, and I think it's FreeBSD. There's a distro called FreeBSD that you can get. And it's not the same as Linux, because BSD, I believe, uses a different kernel. Linux is actually just refers to the kernel. So, and it gets the name from, is it Linus? I've read it's pronounced Linus.
Linus Torvalds, kind of
Yeah.
like, it's kind of after
Yeah, yeah. So Linus Torvalds, or Linus Torvalds, is the guy who created the Linux kernel. He's was a Finnish student at that time in Finland. And he named the kernel program that he was developing Linux based on his first name, and then combining that with Unix. So you can run FreeBSD if you want to. I've installed it. I have it installed in a virtual machine. I haven't really messed with it too much. And it's going to be similar, but it's enough different that there's a learning curve involved if you want to switch from, say, Ubuntu to FreeBSD. There's a little bit of a learning curve involved. My computer? Yeah. I'm running on battery. Now, there was other shells that were created. When I started using Unix, I used a shell which was called the C shell, CSH. It was called the C shell. And I think that was the shell that was developed and released with Berkeley, with BSD. Berkeley's known as BSD, the Berkeley Software Distribution. That's what BSD means. And so you can run the C shell. Most of these shells, the common ones, are installed. So if I want to run the C shell, I can just type a command, CSH. I don't have it installed. I can install it. I'm not going to, but I don't actually have it installed. There's another one called the Z shell, which is ZSH. And I don't have that one installed either, but you can install it. So it looks like I was wrong when I said that there'll be several shells installed. Looks like at least my version of Linux, XFC, I have to install the shells separately. But there's going to be one shell installed, and most likely it's going to be Bash. And Bash is an acronym. Let's just search for Bash. So Bash is known as the Bourne Again Shell. So B-A-S-H. Bourne, B-O-U-R-N-E, is the guy who wrote the shell. And he just named it after himself. And Bourne Again Shell makes Bash, and that's a nice little term. Oh, Corn Shell. There's one called the Corn Shell, KSH, and C Shell. And then Free, what was it called?
There was Fish and ZSH. Those are like the two popular ones.
Right. In Ubuntu, you can install ZSH. It's in the package repository. You could install it. If you're running an Ubuntu-based distribution and you want to install a package, if you know the name of the package, then you can type a command. You would do sudo to switch to super user mode, because normal users can't install packages. And then you would do apt get, and then here you would type the name of the package that you want to install. And if you're using an Ubuntu-based distribution, if you want to know what packages are available, let's see. I have a link somewhere. Yeah, I can't find it right now. Just do a search, Ubuntu packages. That'll bring you to this page. And on this page is a list of various versions of Ubuntu. I'm actually running a very old version. I'm running 16. They're up to 19. And then if you scroll down, you can search the contents of packages. So let's say I know that I want to install the Z shell, but I don't know the name of the package. It might not be ZSH, it might be something else. Then you can type ZSH here in the keyword box, and then you can do search. And then it'll come up with a list of packages where ZSH is contained somewhere within that package. And the first one I get, bin ZSH, that's the Z shell that I want to install. So now that I know the package name, I can come back here and I can do ZSH. And I have to switch to super user mode, so it asks me for my password, if I can remember it. Okay. And then for some reason, oh, it's apt-get install, sorry. Sudo apt-get install package name. Okay. And then it'll go through and it'll tell you how much space is going to be used on your disk. Okay. And then it starts downloading the files and it'll get installed, and then after this finishes I can type ZSH to load the Z shell. So in theory it's installed now. And if I type ZSH at my terminal, okay, so I'm in my terminal, and I'm running bash, if I type ZSH, it'll load the Z shell. And I can start running using the Z shell to type commands. And each of these shells do the basic thing is they give you a prompt string, you type a command, they do something to execute the command. I mean, in general, that's what a shell does. But they have extra features. And so you're going to find that bash has some features that Z shell doesn't have, and you're going to find that Z shell has some features that bash doesn't have, and so on like that. And if you find one you like, then, you know, by all means run that one. So Z shell is a nice one. I've not played with it too much. And I'm sorry, again, the last one you mentioned is fish. Yeah. This one I'm not familiar with, the fish shell. So I'm going to have to look into that. Yeah. Okay. Well, anyway, let's go back to bash, because by default you're probably running bash. In my manual, you can type cat/etc/shells, and that will show you the shells that are installed on your system. Or you can type chsh-l, and what's that do? I must have something wrong. Huh. Well, I've got a typo in my manual or something, because when I type -l as an option, it won't take it. So that must be a mistake. Let's try cat/etc/shells. Okay. That command works. Cat is a program, a command that you can run. It's a program. It's written in C, probably. And it stands for concatenate. And concatenation, when we talk about concatenation in programming, we're usually talking about strings. And you can take two separate strings and put them together to create one string. And that's called a concatenation operation. In this context, I don't really know why they call it concatenate, but the program's called cat. And what it does is, if you say cat file name, it'll display the contents of that file. It just scrolls it to the terminal. That's all it does. In Windows, there's a command called type, I think it is. You can say type file, at the command line, you can say type file and it'll display the contents of the file. It just scrolls it to the screen. Okay, I knew it was something like that. Yep. So I actually have sh dash bash rbash and z shell now. I'm not sure what rbash is. I'm not sure what it is. When you're in your terminal, if you want to log out, essentially close the terminal program, there's two ways you can do that. You can click the X button, or you can hit Control D. And if I do that again, it logs me out. Before graphical interfaces came along, a user would log into the system and everything would be text-based. And then when the user wanted to log out, you just hit Control D. And Control D is the character that's used in text files to represent the end of file. So every text file in Linux will have a Control D character at the end, and that stands for end of file. And so you would type Control D at the command line, and you're sending end of file to the terminal program, and the terminal program says, okay, you're done. So it logs you out. That's kind of handy to know because you can run a terminal within a terminal, or you can run a shell within a shell. So let me open my terminal window back up. So right now I'm running bash. If I want to run another shell, like Z shell, I can simply type Z shell, and then it starts up the Z shell. Now my bash shell is still running in the background. If I open another terminal window, and I do top, I was wondering if bash would be in here. Yeah. So notice that in my list of processes that are running, I'm running bash, I'm also running Z shell, and I'm also running bash. I'm running bash twice because I started bash up in this window, and then I opened another terminal window which is running bash. So I have two instances of the terminal bash running. And then I'm running Z shell because in this one I started up the Z shell. Now, when you're in a shell, if you hit Control D, like I'm in Z shell now, if I hit Control D, it logs me out and sends me back to bash. And if I hit Control D now, it's going to log me out of bash and close my terminal window. So you can run bash, 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 and now I have 4 instances of bash running. I've got the original one and 3 other instances of bash. So if I hit Control D, it'll log me out of the last instance. One more sends me back to the second one. One more Control D sends me back to the first one. And one more logs me out. Now there's not a good reason to run bash within bash, but you can. What I find that convenient for is sometimes I want to do something in a different shell. So I can just temporarily start up that other shell, do my thing, and then log out and go back to bash. And if you want to, you can change your default shell. You use this CHSH. I guess that stands for change shell. You would say change shell -s and then give the name of the shell you want to run. But I'm going to presume everybody's using bash. Now, if you get an account on that machine called General, let me log into General. The way you connect to General is through a program called SSH. So at the command line, if you have an account on General, then you can type SSH. That stands for Secure Shell. And what that does is it allows me to connect to General, and the data that gets sent back and forth will be encrypted. So I would type my username, your ASU username, and then @ general.sh. bash.asu.edu. And it's going to display a prompt to ask me for my password. Okay. And now I'm logged into General. And so if I look at my files now in my folder, the ls command, ls stands for list. So at the terminal window, if you type ls, it'll display the files that are in that directory that you're in. And so the files I'm looking at are the files that are stored on General, not on my hard drive. Okay. I'm going to log out of General now. By default, whenever you're in the terminal, this string that gets displayed right here, this is called your prompt. And you can change the default prompt in Bash is a $sign. So if you don't do anything special and you fire up Bash, you should just see a $sign. And that's the shell's way of telling you it's waiting for you to type a command. Now what I've done is I've modified my prompt so that it displays the name of the machine I'm connected to. So right now I'm logged into Babbage. That's my personal computer. And if I log into General, notice that when I logged into General, it says General in the prompt. That's convenient if you're logged into a bunch of systems all at the same time, because you can easily lose track of which system you're logged into. So, and you can edit this prompt. So in Bash, there will be a folder that gets created in, not a folder, in your, well, let's start from the beginning. When you create or install your system and you create your own user account, you get your own space on the hard drive where you can store your files. That's called your home directory. And in your home directory, there will be some files that start with a dot. Now, I'm in my home directory right now on Babbage, my personal computer. And if I type ls, it displays the files that are in my home directory. And most of these are folders. You can set the coloring of things. So I have it set up so that folders or directories are displayed in blue. If I go to user bin contains a lot of binary executables, and I have mine set up so executable files are displayed in green. I have it set up so archive zip files are displayed in red. The way you change those things is go to your home directory, and these are stored in what are called hidden files. And hidden files really aren't all that hidden. They just start with a dot. But when you do an ls command, it doesn't display the hidden files. So if you do ls-a, it will display all files. So the hidden files get included. And the files that you see that start with dots are hidden files. And they're not really hidden. Everybody knows they're there. It's just that they're hidden from ls, and they don't show up unless if you specifically request them to. There will be a file in your home folder called .bash profile. This one. It might be hard to read, but that's .bash_profile. And there's another one called .bashrc. And let me fire up bash profile. The default editor in Xubuntu is called Mousepad. So that's my text editor. So if I want to edit that file, I type Mousepad and then the name of the file. Now bash profile doesn't have much in it. Basically what bash profile contains is a command, which this command essentially says if the file that's what the F means, if this file named .bashrc, which is in my home folder, tilde is used to represent your home folder, your home directory. So that says, look in my home directory for a file called .bashrc. If that file exists, that will be true. If it doesn't exist, that will be false. And notice I've got a logical AND here. So if this is false, it doesn't do the other part of the AND operation. And if it is true that the file does exist, then this dot, I think, stands for source. And if you say dot some file, some executable file, that will cause bash to execute that file. So all it does is simply load bash RC. So let's look at bash RC. Now this one has stuff in it, some of which will be added when you install Linux on your computer, and other stuff you can add yourself. Whenever you log in, let's see, I get confused between these. Let's look this up, because there's a difference between what goes in bash profile and what goes in bash RC. See if I can figure this out real quick. Yeah, here we go. .bash profile is executed for login shells, while .bash RC is executed for interactive non-login shells. So when you log in at the console, terminal console means the same thing, or that way, .bash profile will be executed. And that happens before you get the prompt to enter your commands. If you've already logged into your machine and you simply open a new terminal window, then bash .bash RC is executed before every terminal window displays the prompt. That's the difference. Bash profile is executed once when you log in. Bash RC is executed every time you open a terminal window. So if there's initialization that you want to do before you start using the terminal, you can put those initialization commands in .bash RC. And I'll just show you my bash RC. This was put there by Xubuntu when I installed it. So I don't know exactly what that does, but I just left it there. The directories where binaries are stored, the bash will search this environment variable called path. So what path contains is a list of directories. It's path equal directory, colon, directory, colon, directory, colon, and so on. When you type a command, some commands are built into bash, so bash will just execute the command itself. Other commands are binary programs that bash will run. And so what the path environment variable does is it specifies the directories for bash to search for the binary. So if I type something like that, it's going to search first, $home is your home directory. This is kind of like a bash shell script. We're doing a little bit of programming here. And this is called an environment variable. So when you're logged into bash, you've got an environment. That's your environment. And there's variables that are associated with your environment, like global variables. And you can change some of these variables in different ways to make bash do different things. And one of the environment variables that bash depends on is called path. And path is a list of directories to search for when you type a command. If you want, like for example, I have a directory called bin. Bin is short for binary. And you'll see bin in Linux, and it stands for binary. For example, I mentioned there's a directory out here called user bin. Bin means binary. User bin is a bunch of binary files that are executable. So this says I've got my own bin directory and my home directory. If I go to my home directory, oops, okay, /home/Kevin is my home directory. Now, I don't know if this is true of Arch and other distros. I mainly only know Debian-based distros, but by default, your home directory is going to be /home/ and then whatever username you create when you create your account. And that's where your files get stored. And I've got a directory out here called bin, which contains a bunch of bash shell scripts. It's a convention in bash that shell scripts end with a .sh extension. So I've created several shell scripts that do different things. I've got one called general.sh, which I use to connect to general. It does some stuff and then connects to general. So when I type a command, I want bash to search my home bin directory first for the command. And so in my bash rc, it'll search these directories in order. So it'll look in home bin, and if it's not there, okay, then it's going to look in a directory called /opt_mars. Mars is a MIPS simulator that is used in CSE 230. If you take 230, you'll learn assembly language, and Mars is a simulator that simulates a machine, and you can use that simulator to run your assembly language program. So I installed Mars on my personal computer here, and the directory where Mars is stored is in /opt, this directory. Opt stands for optional, I guess, and it's sort of a convention that binaries which are not part of standard packages, you put the files for the program in opt. That's sort of a convention, but you don't have to do that. It's just sort of a convention. So the packages that you install, those will get installed into directories like user bin and stuff. But I had to download Mars separately, and so I stuck it in my opt directory. And I have various programs that I've installed out here, including Firefox. So that's what path does. When you access an environment variable, let's say that let's say every time I log in, this is kind of a silly example, but let's say every time I log in, I want to display the contents of my bin directory for whatever reason. So I can put a command in here. ls stands for list, and that's the command that lists the contents of a directory. And you can give an argument to ls, which is the directory you want to list. And so if I want to access home bin, okay, I can write this. And this says, go to home. Okay. So you access an environment variable by putting a $sign before it. So home is equivalent to /home/Kevin. Yours will be /home/ whatever your username is. And so when I want to use an environment variable in a shell script, you put a $sign in front of it. And optionally, you can wrap that thing in a pair of braces, which I usually do. And that's just I don't know that the braces really do anything, but I oftentimes do that anyway. So there's a command now that whenever I fire up the terminal, it's going to display the contents of my bin directory. Okay. So what this command's doing right here is it's taking the path variable, which already existed before I did this command, and it's concatenating onto the end of what path was. It's concatenating those directories. So let's suppose at the beginning path was equal to, it's going to be something like /bin/user/bin. Okay. it'll probably contain /bin and /user bin. So let's suppose that's what path was. When I do this command, it's going to replace the environment variable. It's going to replace the value of the environment variable with that. And so I've concatenated onto the end of what was path. I've listed some more directories to search. Okay. So I have Microsoft Studio installed here, and I want it to search that directory because when I type the command to load Microsoft Studio, I need bash to figure out where that executable is stored. And then after you do that, for some reason I'm not quite clear, but in bash, after you create an environment variable and assign a value to it like that, you have to do an export statement. What will happen when you run a shell script, you can create environment variables, but those variables go away when the shell script terminates. They're just local variables. And if you want those variables that you're assigning values to essentially be global variables, so they're accessible to all of bash, as opposed to just this particular script file, then you export the environment variable. And in essence, that turns it from a local variable into a global variable. So I've changed path, and I want that path environment variable to be sort of global. So after I change it, I export it. I'm going to change this back to the way it was. There we go. If you want to change the prompt, so right now, my prompt, I've got it set up so it displays my machine name in brackets, and then it displays my current directory. And Linux, just like Windows and Mac, you have directories or folders where you can store files. And so I've set mine up so it always displays what's called the current directory, or the current working directory. The current working directory in Linux and Unix is the directory where you happen to be when you perform a command. So if I type ls now, it's going to display the contents of this directory because that's the directory where I'm at right now. That's my current directory. I think there's a command. Nope. It's pwd. There's a command called pwd, which stands for print working directory. So if you don't know where you're at, now I've set my bash prompt up so it tells me my current directory, but if you don't have that and you don't know what your current directory is, you can type pwd and it'll tell you the directory you're in. I like to know what directory I'm in, so I've modified my prompt so it displays it. The way you modify your prompt is there's an environment variable that you can modify, and I'm trying to find it here. PS. There's an environment variable called PS1 and prompt string 1, and you can configure this to display whatever you want. So this is kind of nasty because I've got some codes in here because I want to display things in colors, and the way you do that is sort of old-fashioned and archaic. But notice that my prompt is displayed in red. By default, it's just going to be black, but for some reason I wanted it to be red. So this verbiage says switch to red. And then this, in brackets, I've got \h. That stands for home. Or no. Well, I don't know what that stands for. I was going to say home, but that doesn't make sense. It's my machine name. So I've named my machine Babbage, and so I want to display my machine name in my prompt. So it'll switch to red, display the machine name in brackets, display the working directory, and then this displays a $sign and a space, and then this switches me back to black. So I change to red, do this stuff, change back to black. So that's why I see the brackets with my machine name, that's that stuff, and then my current working directory is /user_bin, that's that. Then I've got a space and a $sign and a space, and then now I'm back in black mode and I've got my command. If you want to modify your prompt and change it to do different things, if you type man bash, that will bring up the man page for bash. And it's a pretty long page, because bash is a pretty complicated program. But if you search here, when you do man, and you fire up a man page, if you want to search the page for some text, you type a /. So if I type /, and I want to learn about this prompt string, so I'm going to type /PS, and it will search this page for every occurrence of capital PS. Unlike Windows, Unix and Linux are case-sensitive operating systems. So it matters when you type a command if you type lowercase versus uppercase. Windows doesn't matter. Windows is not case-sensitive, but Linux is. So this says search for capital PS. And did it find anything? Oh, it found PS in synopsis. Anyway, if you want to keep searching, you just hit / again. So every time I hit /, it'll search forward. Okay. And there's, oops, I had it, and then I just, I had it right in front of me, and I messed it up. Well, let's do that again. Hmm? Oh, there is. I think, let's try this. I think F, well, not in man. Not in man. I don't know how to do it in man. But some of the Linux programs, I'll show you this. There's a command called more, and there's a command called less. And what more is traditionally used for is if you want to display the contents of a file, but you want it to just display one page, one screen at a time. Suppose I want to display the contents of I'm trying to think of a big file somewhere that consists of more than one screen. There's a big file. It's 23.4 kilobytes. So suppose I want to display the contents of that file, and I'm at my terminal window. That file is brlttyconf. So I could do a cat command, and I could say cat /etc /brltty.conf. Okay. And it displays the contents, but the whole thing scrolled by me so fast I couldn't see any of it. So in Linux, you can do what's called a pipe operation. And basically what pipe allows you to do is you can take the output from one program and feed it as the input into another program. So the output from one program becomes the input to another program. And you use a vertical bar, and that stands for pipe. So if I say cat that pipe more, then the output from cat is going to be the contents of the file, and more will read that as the input. And what more does is it displays one screen at a time. And then you can go down by hitting F forward and B backward. Now more is kind of outdated, so there's another program called less. And less has more features than more. It should be called more plus, right? But if I pipe the contents of that file through less, it'll stop, and I can scroll down and up and down using my page keys. And I think I can search here using /forward. So let's just suppose we search for AI. And it'll show me all the contents of AI within the file. Okay. So that's a very convenient thing to do. A lot of times you've got a file and you don't want to bother loading it up into the editor. You just want to look at it real quick. that's a quick way to display the contents of a file so that you can scroll up and down and look at the contents that way. Let's see, it's 8:08. I was planning on being home by this time. How long have we been going? An hour and a half? Yeah. We planned on 4 of these because I actually have, I think, enough material to, and you guys are always welcome to bring questions. So I planned on 4 of these. We might have 6 if we need them and whatever. We can be flexible. But the plan was to have 4 of these 1-hour workshops, and it's probably going to take me more time to explain everything I'd like to explain in 4 hours, but yeah. Yeah. We're planning on having these meetings every 2 weeks, right? And for right now, it's going to be these workshops, but after I finish, there are going to be possibly another workshop or something. So I think the club is planning on meetings every Wednesday. Yeah. So I think we'll stop here. But before we go, let's answer any questions you may have right now.
I was wondering if you knew how to switch, transfer files from one user to another, from root to a user.
So you've got a file that's in a directory that root can access,
Yeah.
and you want to access it as a user, but you don't have privileges to say load that file, or you can't edit it.
I can't even find the file, the directory as the user.
Do you know the name of the file that you're searching for, or part of the name?
Yeah.
Okay. There's a command called find, and do man find.
Yeah, I've used find.
Find is a little bit difficult to use.
Yes.
So I actually have a shell script that I wrote because I couldn't remember the arguments to find. I'll show you my shell script. It's in my bin directory. Okay. So this is my find shell script. I've got a function that just displays a help message. So if I was going to talk about shell scripts too, but that may need to be for a future workshop, but we'll see. But this is a shell script. It's a program that the shell executes and runs. So I've got a function that displays help. So the shell script actually starts executing right here. And this says, in English, if there are less than 2 arguments on the command line, then display the help message and then exit, terminate the script. Otherwise, if there are 2 arguments on the command line, then my assumption is the first one is the directory I want to start searching in for the file I'm looking for, and the second one is the name of the file I want to search. So the command that you would do is find, and then the directory where you want to start searching. You can put / here for root, the root directory, and it'll search the entire disk. But if you know the file's in, say, the etc directory or some directory below that one, then you could say find /etc. And then instead of searching at the top of the directory tree, it'll search the etc subtree. And then the second argument is the name of the file that you're searching for. And I don't know why I have -no warn there. So you would say something like find etc xyz.conf. That's interesting.
There's probably little arguments that we need.
Did you get it to work?
I have in the past. I forgot
Okay.
the arguments though.
The way I do it is I got my shell script, but what my shell script does is it executes fine. The first argument is my starting directory, and the second and then I do -iname. That's what I forgot. -iname. That says search for the file that follows this iname option. So that's the name of the file I want to search for. you do dash name. Dash iname says ignore letter case. So it'll search for both uppercase and lowercase file names.
So would I write the file name before dash iname or after?
After. So you would do find slash etc. for example, dash iname, and then the name of the file that you're searching for.
Yeah, that's really weird because I did that and I know the name of the file and it's not showing up.
No.
I don't know. I could show you and
Yeah. Well, I'll just take a look at it then. Any other questions? Yeah.
When you were typing your commands, I noticed the thing you were doing, suppose Z shell.
Yeah.
And then you were putting an exponent and a C, capital C. So I was wondering why you were doing it. It was like an ignore.
Oh, yeah. When I fired up Z shell, and then I didn't want to proceed with this. First of all, my prompt string is all weird. When you're running a command, if you want to, like a process and it's taking a long time and you want to kill that job, you hit Control C. So if I hit Control C, it's going to kill this job. Oh, well, I was trying to hit Control C is not working. I hit Control D to exit. But suppose you're running a job. Now I'm searching the entire directory structure for a file named A, and that's taking a while and I'm bored and I want to stop. Then you can hit Control C, and Control C kills a job. It kills the job that's running in the foreground. You can also set it up so that you can run jobs in the background, and if we have time I want to talk about that. But yeah, Control C is how you kill a job that's running. If you have a job that's running and you want to kill it, another way to do that is there's a command called kill. And kill takes an argument which is the process ID of the job that you want to kill. So if we go to top again, this is a list of all the processes that are running, and the first column gives you the process ID. So I'm running Bash, and Bash has process ID 26084. Now I'm actually running multiple copies of Bash, so if I kill this, I don't know which one I'm going to kill. But you can type kill 26084. And it'll kill that process ID. Now I'm running multiple windows, and so I killed one of them. I don't know which one. But that's how you can kill a job too, is you can say kill. You need to know the process ID, which you can get from top. And to log out is Control D. Yeah. Any other question? Yeah?
So what was the other way to that?
Oh, this is my text editor. So I'm running Xubuntu, which is Ubuntu with the XFC desktop interface, and the default editor in this environment is called Mousepad. Yeah. If you know the name of the binary, you can just type the name there at the terminal and run it. Otherwise, I have a link in my start menu, and I can load it that way. But any binary you can run from the command line if you know the name of the command, the name of the binary. You just type it at the command line. So Thunar is the file explorer in XFCE. So if I type Thunar, it'll load up the file explorer. Any other ones? Well, come next week with a lot of questions, and we'll try to answer them, and I'll go over some more things. I have quite a bit of stuff I can go over, so I don't want to bore you by talking about things you already know, but there's a lot of stuff that we can cover, and so I want to make sure that when we finish that you've learned enough that that you've learned the stuff that you want to learn, and hopefully some more. Yeah. So I'll see you guys next week. Thanks for coming. We really appreciate it.